My name is Tom McDermott, and I'm a researcher in power electronics and power systems at Pacific Northwest National Laboratory. In IEEE standards, I've contributed to 1243 and 1410 for lightning protection, 1729 for distribution system analysis, and the 1547 family for DER interconnection. In IEC standards, I've contributed to 61968 and 61970 for the Common Information Model. That experience provided crucial information about industry requirements to help guide my research and opportunities to reach a wider audience. Here, I will provide a researcher's overview of how standard making works and offer reasons why you too should be interested. The cost of solar generation has decreased rapidly over the last decade, especially for utility-scale solar and hardware cost components. Unfortunately, the soft cost components remain stubbornly high, especially for residential and commercial solar. Soft costs include labor, permitting, commissioning, and other components that are influenced by standards. One such standard, IEEE 1547-2018, recently defined ride-through and smart inverter functions for DER. These new capabilities could make a difference in design and operations, but fewer than 10 states have adopted them so far. Until they do, those functions won't be deployed on a national scale. Advanced methods from your research projects are even further from deployment. They can't be used without standards, products, and test procedures. Any delay in developing or adopting standards will impede the deployment of more solar generation. For another lab perspective, let's hear from Ben Kropowski of the National Renewable Energy Laboratory.
Being involved with standards has really helped my career. One of the biggest benefits is being able to interact with some of the top experts from around the country. You can really get into some deep technical discussions during the standards meetings and learn a lot from them. Another benefit is being able to develop your project management and leadership skills. I've been a secretary and chaired several standards. This experience has really helped me develop those skills inside my career.
In the United States, IEEE working groups develop many of the pertinent standards. The IEEE Standards Association is separate from the technical societies and regions, which you might be more familiar with. You can participate in these working groups without joining IEEE SA, but I recommend that you do join for the opportunity to vote and comment on standards. IEEE standards follow a 10-year life cycle which repeats many times. IEEE 1547 was revised in 2018, and a new project was just authorized to start its next revision. There are 3 strength levels of these standards. For example, IEEE 2800-2022 is a standard on requirements that IBR shall meet when connected to the bulk power system, but it doesn't say much about why or how to meet those requirements. For that, IEEE P2800.2 will be a recommended practice on how test and verification should be done. For DER interconnections, IEEE 1547.2, currently in revision, is a guide with more technical background, including alternatives that may be chosen in different situations. Research teams are more likely to engage with working groups developing a recommended practice or guide at the should or may strength level. Those groups can use information about new proven methods. For solar grid integration, the relevant IEEE standards are developed using the individual process rather than the entity process. The individual process is more accessible to researchers, which is another reason to consider joining IEEE SA. The IEC standards are developed for an international audience. Voting is done by country with a 2/3 threshold for approval, but individuals appointed by their national committees develop the standards and contribute to their country's voting decisions. In the United States, one joins the American National Standards Institute, ANSI, to participate formally, but informal participation is also possible. There is a multi-year process defined for developing new IEC standards and revising them. The acronyms and stages are different from IEEE's process, but the functions are similar. For example, the IEEE Project Authorization Request, PAR, roughly corresponds to the IEC's New Work Proposal, NP. For solar grid integration, IEC 61850 has produced an object model for DER, which is referenced in IEEE standards like 2030. We've recently added dynamic models for DER and IBR to the Common Information Model in IEC 61970, Part 302. This may lead to more interoperability of models between software tools. Over half of the IEC in-person meetings have been outside the United States. However, some researchers have been invited to make virtual presentations or other contributions. For an industry perspective, let's hear from Jens Boehmer of the Electric Power Research Institute.
I got involved in standardization back in the 2000s with the German VDE. The very first day I joined EPRI in 2014, I was on a plane to an IEEE 1547 working group meeting. Engaging and eventually leading standardization of technical interconnection requirements for DERs and large IBRs, such as in IEEE 2800, gave me the opportunity to transfer our EPRI innovations and to widen my professional network across many different stakeholders in North America.
The North American Electric Reliability Corporation, NERC, establishes reliability requirements for bulk power transmission. NERC has enforcement powers and is accredited by ANSI to develop standards. Like IEEE and IEC, it has a formal development process that repeats as needed. There is a standard authorization request, SAR, comparable to IEEE's PAR and IEC's NP. The voting approval threshold is 2/3 based on representation from 10 industry segments. Unlike IEEE and IEC, staff at NERC make technical contributions and provide leadership in developing NERC standards. For solar grid integration, the NERC reliability guidelines have informed much of the recent work on the IEEE 2800 family of standards for bulk power connections of IBR. NERC has also begun to encourage transmission planners to collect more data for electromagnetic transient and aggregate DER modeling. This may lead to new requirements on hardware and software vendors with opportunities for research as well. Researchers may participate on NERC task forces as individual experts. Researchers benefit from active participation in these SDO working groups. The other participants attend these meetings just to focus on specific problems, and they are well versed in the topic. They have encountered and overcome practical issues. There's no better venue to learn about industry requirements, identify barriers to the adoption of your work, and make contacts for industry collaboration. People in industry are busy and more likely to collaborate with you after they've seen the value of your contributions. Business development also includes the possibility of employment contacts for the students and postdocs on your team. Academic conferences don't serve these purposes as well. They focus on research, particularly in early stages. As you develop ideas to late-stage R&D, an SDO working group could help you navigate the next steps to widespread adoption. For another stakeholder perspective, let's hear from Jeremiah Miller of the Solar Energy Industries Association.
Researchers should participate in standards because they directly support innovation. When companies and vendors agree on what are the requirements to put all their products together, it enables organizations to then use them in innovative ways. Standards are the foundation for how the energy innovation ecosystem happens, and participants can play an active part in saying how the pieces fit together, how we can do all this together and drive consensus around the next generation electric system and the next generation renewable power system.
I hope you'll consider SDO working groups as a venue for technology transfer in your research projects, especially those funded by the DOE Solar Energy Technologies Office. For more information and updates, please look for this SDO page on openei.org. To begin, we have one sample presentation that was given to recent meetings of IEEE 1547.2 and the Power System Relaying and Control Committee. Each group is carefully scoped to avoid conflicts and overlaps with other SDO working groups, which means it can be a challenge to find the right one. We'll add tables of contacts and links to help you with that. We'll also add tables of research projects and contacts to help the SDO working groups find expertise from the other side of this interface.